Welcome you for the presentation. I am Dr. Sangeeta DM, Associate Professor, Department of Civil Engineering, AJIT, Mangalore. Today's topic of discussion is related to arches and cables. In part 1 and part 2, we dealt with the arches. What are the types of arches and some numerical problems also we discussed. And now we are moving ahead with the cable structures, or what are the cables and what are the forces coming on it and how to evaluate the forces in the cables and all. Cables are used as temporary guys during the erection and as permanent guys for supporting mast and towers. So cables are the temporary members or a permanent members as well. The use of towers to support large tents like that of circus tents is well known to all. Cables are also used in suspension bridges. The common types of cables you can see in suspension bridges. Here in the figure you can see a cable which is suspended in between the two towers, and the cable is also suspended, that is provided with the suspenders, and those suspenders are connected to the roadway. So the roadway, whatever the existing roadway will be there, that is connected through the suspenders to the cable. The cable is connected to the mast. The distance between the two towers is known as span, and that is the height of the tower. And the cable is again connected through anchor cable. So these are some of the basic components of a cables. In cable we have different types. One is guided pulley support and the other one roller pulley support. Guided pulley support is a suspended cable. The cable tower is there and the cable is suspended through a guided pulley. It is a frictionless pulley or frictional pulley. A pulley will be there. In that pulley an anchor cable, it is connected to the anchor cable. So that is guided pulley support. And the next, the second one is roller pulley support. The pulley is connected to the roller support. The suspension cable, there will be a pulley and the anchor cable. That in between the suspension cable and the anchor cable there will be a roller support, roller pulley support. And along with that, in the third figure you can see the stiffening girder. Stiffening girder means the stiffeners are directly connected to the cable, and this is commonly observed in bridges with walkway bridges and all those things. Coming to the equilibrium of cable. So always whatever the structure that comes in a civil engineering should be in equilibrium. It may be static or dynamic, but the structure should be in equilibrium. Similarly, a cable, whether it is suspended cable, it should be in equilibrium condition. The expected is the cable, however the condition is, it should be in equilibrium. Primarily, you can see here a cable of length L. Cable is there. The distance between the two supports is I. It is taken as I. At support A, there is a horizontal and vertical force. At support B, there is a horizontal and vertical force. Different loads W1, W2, W3, UDL are acting on the cable. So W1 is acting at a distance A1, W2 at A2, W3 at some other distance, and there is a UDL. So let's consider a load X. A load X acting at a distance small x from support A. In order to evaluate the equilibrium of the cable, the moment at X is taken. Cable is downward. It is a parabolic curve. You can't take the moment at the top end point. Cable is a curved point which is U-shaped. So at the bottommost, at point X on the cable, you are taking the moment. At point X, what are the forces coming out? VA into horizontal distance, then W1 into X minus A1, W2 into X minus A2. There is an horizontal force, let the vertical distance be Y, H into Y. In order to have the cable, in order to find the cable to be in equilibrium, the moment about x should be 0. Since the cable is flexible in nature, and to establish the equilibrium of the cable, the moment at x should be equal to 0. When you equate the equation to 0, horizontal force Hy is equal to the vertical forces Va into x minus W1 into x minus A1 minus W2 into x minus A2. Whatever this vertical forces is known as along the x direction, any point in the beam is called as beam moment. So therefore beam moment is equal to H into Y. Beam moment is equal to H into Y. Considering any segment of the cable and using the above equation along with the usual equations, a loaded cable can be analyzed as, see here the cable subjected to various types of loads. Using the previous equation, H into Y is equal to beam moment, moment of the beam, M beam. Therefore Y, what is the ordinate at Y? Beam moment by H. So therefore if you want to find out Y1, Y1 is equal to M1 by H, Y2 is equal to M2 by H, Y3 is equal to M3 by H. Using these interpolating formulas, you can find out what are the beam moments and what are the ordinates. With this concept, we will proceed with one small problem. Example 1. A light cable 18 meter long is supported at two ends at the same level. A light cable 18 meter long is supported at two ends at the same level. The supports are 16 meter apart. The cable supports 120 Newton load dividing the distance into two equal parts. So you can see here the 120 kilonewton, 120 Newton load is there. It's a point load which divides the cable into two equal parts. Find the shape of the cable and tension in the cable. Find the shape of the cable and tension in the cable. So the length of the cable is 16 meter. The two supports are 16 meter and length of the cable is 18 meter. And there is a point load of 120 Newton. So here is the figure that is depicted the same problem. Support reactions VA and VB is equal to, since the load is acting exactly at the center, the support reactions are exactly half equal in magnitude the total load. So VA is equal to VB is equal to 120 by 2, that is equal to 60 Newton. Now we have to find the length of the cable, then tension in the cable. How to evaluate the length of the cable? So length of the cable, we have the equation L is equal to L by 2 square plus YC square. See here length of the cable, this is the triangle. I want to find what is YC. You can find the half triangle for 8 meter span before the loading and after the loading, it forms a triangular pattern. So if you use Pythagoras equation, so this is L by 2 whole square is equal to Y square plus the ordinate distance. You can use like that or a modified. L is 18 meters, so 2 times of A square plus B square under the root. Like that also you can use. So this is the modified equation. So YC is equal to 4.123 meters. So that is the YC. Taking moment about C point, if you take moment about this point, VA into 8, that is making clockwise, whereas H into YC, that is anti-clockwise. H into YC is anti-clockwise minus VA into L by 2. L by 2 is 8. So what we can find out what is the horizontal force. In order to find the tension in the cable, tension is a diagonal force. So it is equal to square root of vertical force plus horizontal force. What is the vertical force? 60. Horizontal force 116.42. How to understand this? See at that support point E, what is V, what is H, then what is T? That is the concept of resolution. You can use the concept of resolution and find the tension in the cable. So if you solve this, you can evaluate the tension in the force. So this problem is completely solved using basics of your mathematics. One is Pythagoras theorem, then taking moment about C, that is the equilibrium equation, then again Pythagoras theorem. Using the same concepts you can solve this problem, analyze the problem. Further, we are heading for second problem, example 2. A light cable is supported at 2 points 20 meter apart which are at same level. The cable supports 3 concentrated loads as shown in the figure. The deflection at first point is found to be 0.8. The deflection at first point is found to be 0.8 meter. Determine the tension in different segments. Determine the tension in different segments and total length of the cable. Tension in different segments and total length of the cable. See here, the distance between the 2 points is given 20 meter apart and they are at the same level. There are 3 concentrated loads that is shown in the figure at every 5 meter interval. So supports are 20 meter apart, at every 5 meter interval there is a concentrated load. The deflection at first point is found to be 0.8. So y1 is 0.8. Determine the tension in different segments and total length of the cable. Determine the tension. So T1, T2, T3 and T4 you have to evaluate. Find the to start with, and also the length of the cable you have to find out. To start with, you have to find the support reactions. To find the support reactions, taking moment about A. Taking moment about A. A is this point. Take moment about A. Taking moment about A, the cable has to be in equilibrium, so moment about A is directly equated to 0. The same concept we understood in the previous example. Moment about A is equal to 0. So 40 into 5, I will just show here. This is making clockwise movement, so 40 into 5. 30 into 10, again clockwise movement. 20 into 15, clockwise movement. Next comes VB, support reaction at B. VB into 20, that is making anti-clockwise, so negative. So if you solve this, you will find out OB. Then sigma V is equal to 0, VA plus VB is equal to 40 plus 30 plus 20. So minus VB is already known. So what is VA? As of now, we know what is VA and VB. Next, you have to find the beam moments. What is beam moments? Before calculating, I will just take you through a previous slide. Beam moment is H into Y. Beam moment is H into Y. See, in the present problem, you know Y1. You know Y1. So if you know Y1, M1 beam is equal to H is known. H is known. H into Y. So moment at first point, M1 beam is equal to beam moments at point 1, 2, 3. Beam moments at point 1, 2 and 3. So at this point the beam moment is VA into 5. VA is 50 into 5. At point 2, VA into 10 minus 40 into 5. Similarly, beam moment at point 3, 1, 2 and 3 points. So this is first point, second point and third point. Third point, you can take VB into 5. VB into 5. So beam moments at first point, second point and third point, you know beam moments. Along with that, you have the equations. If H is the horizontal reaction, then HY1 is equal to M1 beam, HY2 is equal to M2 beam, HY3 is equal to M3 of the beam. So the corresponding beam moments. In the first equation, HY1 is equal to M1 beam. You know Y1, you can find out what is H. In the second equation, by solving the previous one, you would have known H now. So you don't know what is Y2, you can evaluate Y2, and in the third, you can find out Y3. Here are the steps. Since Y1 is 0.8, you can find out what is H and substitute H in the next equations. Y2 and Y3 are evaluated. Hence, the deflected shape of the beam is shown in figure below. This is the figure. This is the deflected shape and those are the ordinates. Next, once you know y1, y2, y3, h, va, vb, next part is to find the theta. So, theta 1, theta 2, theta 3 and theta 4 are required. Why it is required? You want to evaluate the tension in the cable and also the length of the cable. So, theta is, see the figure here, theta tan inverse of y1 by t1, y1 by phi, tan inverse of opposite by adjacent. So, theta 1 is tan inverse of y1 by phi. So, theta 2 is tan inverse of y2 minus y1 by phi. What is y2 minus y1? y1 is this, y2 is this. I want the difference, y2 minus y1. What is theta 3? Theta 3 is tan inverse of y2 minus y3 by phi. What is theta 4? Theta 4 is y3 by phi. So, correlate the figure, you will get the equations. You already know y1, y2, y3, substitute it and find out what is theta 1, theta 2, theta 3 and theta 4. Next is tension in the segment A1, 1, 2, 2, 3, 3, 4. So, various tension in each cables are evaluated. So, T1, T2 and 40. See the figure, T1, T2 and 40. There are only 3 forces. So, you can use Lamè's theorem, T1, T2 and 40, 3 forces. You can use Lamè's theorem. Lamè's theorem states that a force in a member is the ratio of force in a member to the sine of an angle between the other 2 forces is equal to the force in a member to the sine of an angle between the other 2 forces. So, all the 3 forces are equated. So, here T1 is T1, sine of an angle between the other 2 forces is here T1, 40 and T2. These are the forces. Other 2 forces, what is the angle? 90 minus theta 2. Next, if we come for 40, the sine of an angle between other 2 forces. What are the forces? Here already 180 minus theta 1 plus theta 2. Next, when we come for T2, sine of an angle between other 2 forces. Other 2 forces T1 and 40, 90 plus theta 1. The same thing it is written over here. By interpolating 2 things, you can solve and find out what is T1, T2, because we already know what is theta 1, theta 2. So, you have to find out what is T1. So, T1 and T2. Similarly, consider the equilibrium of point 3 and apply Lamè's theorem over there. Find out the tension in the forces T3 and T4. So, T1, T2, T3 and T4. Tension in all the 4 cables are find out. So, once you know the tension, then length of the cable is the sum of length of each segment. Sum of length of each segment, that is phi into secant theta, phi into secant theta, that is length of each segment is horizontal distance is phi and secant of an angle, that is inclined length. So, apply the basic geometry and this is the inclined length is secant theta 1. So, phi into secant theta 2, phi into secant theta 3, phi into secant theta 4. Substitute and find out what is the length of the cable. So, this is how the cable tension and length has to be found out. Everything is based on your basic geometry. We will just refresh the things which we studied till now. A cable is a temporary guy. So, cable is suspended with the suspenders and there is an anchor cable which is passing away from the tower in order to make the cable stand in place. The distance between the 2 towers is known as span. There are two types of cables. One is guided pulley support and the rollers pulley support. Next one, equilibrium of the cable. The cable has to be in equilibrium. So, at any point the moment is equal to 0. So, if we equate all the loads and find the moment about any point, horizontal force should be equal to vertical force, the beam moment. The vertical forces, whatever the loads are coming, that is equal to beam moment. So, Hy is equal to moment of the beam. Y is equal to beam moment by H. Using the concept, we started with some problem, simple problem. So, in this problem, at the center of the span there is a load, and what is the length of the cable? What is the tension in the cable? It is supposed to be evaluated. So, using the Pythagoras theorem, length of the cable is calculated. Then what is YC? That is the deflection of the cable. YC is evaluated. Then horizontal force is found out by taking moment about the point C. You want to know VA and H, tension in the cable is found out. Next we moved for the one more problem in which we are supposed to evaluate tension and length of the cable. The distance between the loads are found to be 5 meter and various loads are given. Using the equilibrium equations, first taking moment about point A, VB is calculated, then using sigma V is equal to 0, VA is evaluated, then beam moments at 1, 2, 3 points, only beam moments excluding the horizontal force moments are evaluated. Next, in order to the cable to be in equilibrium, Hy1 is equal to m1 of beam. Since we know y1, H is evaluated, then in the second equation, second and third equations, y2 and y3 are calculated. Next, thetas are evaluated at each points. Using Lamy's theorem at point 2 and point 3, T1, T2, T3 and T4s are calculated. Length of the cable is evaluated using the equation phi secant theta, that is from the basic of geometry. You can see the cable dimension, and among sine, cos, tan, secant, cosecant, secant theta is the one which gives the length of the cable because the inclined length. So, length of the cable is evaluated. In the next part, we will be solving with some more numericals related to cables and some more forces that is coming in the cable. As of now, we will end up the session. Thank you.